It is generally not recommended to use non-metallic or NM cable in conduit for pool equipment wiring. NM cable is not moisture resistant. NM cable's insulation is not designed to withstand direct exposure to moisture. In the presence of condensation or water intrusion, the insulation can deteriorate, leading to electrical hazards. Conduit is not a substitute for moisture protection. While conduit provides mechanical protection, it does not seal out moisture effectively. Water can still penetrate the conduit through joints, connections, or damaged areas. Underground feeder, or UF cable, is specifically designed for outdoor use. UF cable has a moisture-resistant insulation and outer jacket that makes it suitable for outdoor applications. It is designed to withstand exposure to water, sunlight, and extreme temperatures. For pool heater and pump wiring, it is strongly recommended to use UF cable. UF cable is specifically designed for this purpose and provides the best protection against moisture and other environmental factors. Use UF cable with appropriate ampacity for the equipment. Run the UF cable through the conduit for mechanical protection. Seal the conduit at all entry and exit points with sealing compound to prevent water intrusion. Follow all local electrical codes and manufacturer's instructions for proper installation. If the conduit is exposed to direct sunlight, it is important to use conduit with ultraviolet or UV-resistant material to prevent degradation. Use appropriate fittings to connect the conduit sections and to secure the UF cable within the conduit. Inspect the conduit and wiring regularly for any signs of damage or moisture intrusion. When selecting the correct size of UF wire for your pool heater and pump, there are several factors you need to consider. These factors primarily revolve around the electrical load of the equipment and the applicable electrical codes, particularly the National Electrical Code, or NEC. Firstly, determine the amperage of the pool heater and pump. Check the nameplates on both the heater and the pump to find their respective maximum amperage ratings. This is the maximum amount of current each device is designed to draw under normal operating conditions. Secondly, calculate the total load. Add the amperage of the pool heater and the pump to determine the total amperage the circuit will need to handle. If there are other devices on the same circuit, include their amperage as well. Thirdly, consider conductor ampacity. The UF cable must have an ampacity rating equal to or greater than the total calculated load. The NEC provides tables, such as Table 310.15b16, that list the ampacity of different wire sizes based on their insulation type and temperature rating. Ensure the UF cable you choose has an ampacity that meets or exceeds the total load requirement. Fourthly, account for voltage drop. Voltage drop occurs when the voltage at the equipment is less than the voltage at the source due to the resistance of the wires. Excessive voltage drop can cause equipment to operate inefficiently or even fail. The NEC recommends limiting voltage drop to no more than 3% for branch circuits. To minimize voltage drop, you may need to increase the wire size. Fifthly, factor in ambient temperature. The ampacity of a conductor decreases as the ambient temperature increases. If the UF cable will be installed in an area with high ambient temperatures, you may need to adjust the ampacity rating accordingly. NEC Table 310.15b2 provides correction factors for ambient temperatures. Sixthly, comply with NEC regulations. The NEC provides specific requirements for wiring swimming pools and related equipment. Ensure your installation complies with all applicable NEC regulations, including those related to grounding, bonding, and GFCI protection. Seventhly, consult local codes. Local electrical codes may have additional requirements beyond the NEC. Check with your local building department or electrical inspector to ensure your installation complies with all applicable codes. Eighthly, choose the appropriate wire size. Based on the above considerations, choose a UF cable size that meets the ampacity requirements, minimizes voltage drop, and complies with all applicable codes and regulations. For example, if the total calculated load is 20 amps, you might choose number 12 AWG UF cable, which has an ampacity of 20 amps at 90 degrees Celsius, provided that the ambient temperature is within acceptable limits. However, for 30 amp load, you would likely need number 10 AWG UF cable, which has an ampacity of 30 amps at 90 degrees Celsius. Ninthly, consider future expansion. If you anticipate adding more equipment to the circuit in the future, it may be wise to choose a larger wire size to accommodate the increased load. This can save you the hassle and expense of having to replace the wiring later. Tenthly, consult with an electrician. If you are unsure about any aspect of the wiring installation, consult with a qualified electrician. They can help you determine the appropriate wire size, ensure the installation complies with all applicable codes, and perform the work safely and correctly. For installing 2-inch non-metallic conduit, remember that while conduit provides mechanical protection, it does not seal out moisture effectively. Water can still penetrate the conduit through joints, connections, or damaged areas. When using conduit, you should seal the conduit at all entry and exit points with a sealing compound to prevent water intrusion. Also, if the conduit is exposed to direct sunlight, it is important to use conduit with ultraviolet or UV-resistant material to prevent degradation. Finally, use appropriate fittings to connect the conduit sections and to secure the UF cable within the conduit. Inspect the conduit and wiring regularly for any signs of damage or moisture intrusion. Understanding ampacity and selecting the correct wire size for your pool heater and pump is essential for ensuring electrical safety and proper equipment operation. Always err on the side of caution and choose a wire size that is larger than the minimum required. Finally, always follow all applicable codes and regulations. When dealing with pool equipment, proper grounding and bonding are absolutely critical for safety. These measures help to minimize the risk of electric shock by providing a low resistance path for fault currents to return to the source, tripping the circuit breaker or GFCI. Firstly, grounding refers to connecting the electrical system to the earth. This is typically done by driving one or more ground rods into the ground and connecting them to the electrical panel with a grounding electrode conductor. The purpose of grounding is to provide a reference point for the electrical system and to help stabilize voltage. Secondly, bonding refers to connecting all metal parts of the pool and its equipment together with a solid conductor. This includes the pool's metal structure, metal conduit, metal pump housings, metal filter housings, and any other metal components within 5 feet of the pool. The purpose of bonding is to create an equipotential plane, which means that all metal parts are at the same electrical potential. This minimizes the risk of electric shock by preventing voltage differences between metal parts that could cause a current to flow through a person. Thirdly, the National Electrical Code, or NEC, provides specific requirements for grounding and bonding swimming pools and related equipment. These requirements are outlined in Article 680 of the NEC. Some of the key requirements include using a number 8 AWG solid copper bonding conductor, connecting the bonding conductor to all metal parts of the pool and its equipment, and ensuring that the bonding conductor is accessible for inspection. Fourthly, ground fault circuit interrupters, or GFCIs, are another critical safety device for swimming pools. GFCIs are designed to detect even small amounts of current leakage to ground and to quickly trip the circuit, preventing electric shock. The NEC requires GFCIs to be installed on all circuits that supply power to pool equipment, as well as on receptacles within a certain distance of the pool. Fifthly, regularly inspect grounding and bonding connections to ensure they are tight and free of corrosion. Corrosion can increase the resistance of the connections, which can compromise their effectiveness. Clean and tighten any corroded connections as needed. Sixthly, test GFCIs regularly to ensure they are functioning properly. Most GFCIs have a test button that you can press to simulate a ground fault. If the GFCI does not trip when you press the test button, it should be replaced immediately. Seventhly, never modify or bypass grounding or bonding systems. These systems are designed to protect you from electric shock, and any modifications or bypasses can compromise their effectiveness and create a serious safety hazard. Eighthly, hire a qualified electrician to perform any electrical work on your pool. A qualified electrician will have the knowledge and experience to ensure that the grounding and bonding systems are installed correctly and that they comply with all applicable codes. Ninthly, follow manufacturer's instructions for grounding and bonding pool equipment. The manufacturer's instructions may provide additional details or requirements for grounding and bonding specific types of equipment. 10th, be aware of the signs of electrical problems in and around the pool. These signs may include tingling sensations when touching metal parts of the pool or its equipment, unusual noises or smells, or flickering lights. If you notice any of these signs, turn off the power to the pool immediately and consult with a qualified electrician. Understanding and implementing proper grounding and bonding techniques is essential for ensuring electrical safety in and around swimming pools. By following the NEC requirements and taking the necessary precautions, you can minimize the risk of electric shock and create a safe environment for yourself and others. Always err on the side of caution and consult with a qualified electrician if you have any questions or concerns. For using sealing compounds and the conduit, here's some more information. When selecting and applying sealing compounds for electrical conduits, especially in wet locations, several factors should be considered to ensure a reliable and long-lasting seal. These factors include the type of sealing compound, the application method, and the environmental conditions. Firstly, the type of sealing compound matters. There are various types of sealing compounds available, each with its own unique properties and applications. Some common types include epoxy-based compounds, silicone-based compounds, and polyurethane-based compounds. Epoxy-based compounds are known for their excellent adhesion and chemical resistance, making them suitable for harsh environments. Silicone-based compounds offer good flexibility and temperature resistance, while polyurethane-based compounds provide good abrasion resistance. Secondly, consider the compatibility of the sealing compound with the conduit material. Ensure that the sealing compound is compatible with the material of the conduit, whether it is PVC, metal, or another material. Incompatible compounds can cause corrosion or degradation of the conduit material, compromising the seal. Thirdly, surface preparation is key. Before applying the sealing compound, ensure that the surfaces of the conduit and fittings are clean, dry, and free of any contaminants such as dirt, grease, or rust. Use a suitable cleaner or degreaser to remove any contaminants and allow the surfaces to dry completely. Fourthly, apply the sealing compound evenly. Apply the sealing compound evenly and uniformly to the surfaces to be sealed, following the manufacturer's instructions. Use a brush, applicator, or caulking gun to apply the compound, ensuring that all gaps and voids are filled. Fifthly, allow sufficient curing time. Allow the sealing compound to cure fully before exposing it to moisture or other environmental factors. The curing time may vary depending on the type of compound and the ambient temperature. Refer to the manufacturer's instructions for the recommended curing time. Sixthly, consider the temperature resistance of the compound. Choose a sealing compound that is suitable for the temperature range in which the conduit will be installed. Some compounds may become brittle or soften at extreme temperatures, compromising the seal. Seventhly, look for water resistance. Select a sealing compound that is specifically designed for wet locations and offers excellent water resistance. The compound should be able to withstand prolonged exposure to water without degrading or losing its sealing properties. Eighthly, consider chemical resistance. If the conduit will be exposed to chemicals or other corrosive substances, choose a sealing compound that is resistant to those substances. Check the manufacturer's specifications to ensure that the compound is compatible with the chemicals in question. Ninthly, adhere to safety precautions. When working with sealing compounds, follow all safety precautions recommended by the manufacturer. Wear appropriate personal protective equipment, such as gloves and safety glasses, and work in a well-ventilated area. Tenthly, inspect the seal regularly. After the sealing compound has cured, inspect the seal regularly for any signs of cracks, gaps, or other damage. Repair any damaged areas promptly to prevent water intrusion. Understanding the different types of sealing compounds and following proper application techniques are essential for ensuring a reliable and long-lasting seal in electrical conduits. By selecting the right compound and applying it correctly, you can protect your electrical system from moisture and other environmental factors. Always follow the manufacturer's instructions and consult with a qualified electrician if you have any questions or concerns. For the UF cable and the conduit, always consult the NEC or local electrical codes.